Welcome to my channel Teen Tech. It is the part 6 of the operating system. So here we are covering two topics. First one is all about resource abstraction and second one is all about user mode and kernel mode. Here, firstly, let's talk about resource abstraction. Here, resource abstraction is nothing but the operating systems not only shares resources like memory, CPU, and storage, but also hides the details of how hardware works. This is called resource abstraction. Here, let me explain in you detail. Here, in addition to the responsibility of a resource allocation, the operating system is also responsible for the resource abstraction. Resource abstraction is the process of hiding the details how the hardware operates, thereby making computer hardware relatively easy for an application programmer to use. One way in which the operating system might implement resource abstraction is to provide a single abstract disk interface which will be the same for both the hard disk and floppy disk. Such an abstraction saves the programmer from needing to learn the details of the both hardware interface. Instead, the programmer only needs to learn the hard disk abstraction provided by the operating system. Here, in short, resource abstraction makes using hardware easier for programmers by hiding the complex details. Now, for example, normally a hard disk and floppy disk works differently, right? If there was no abstraction, a programmer would have to learn how each one works to read or write a data. But the operating system provides a single disk interface, like a common way to talk to both, right? So the programmer only needs to know how to use that interface, not how each device works internally. And many of these people ask, why is this useful? Imagine a programmer writing a program to analyze stock market trends. Without abstraction, they must also write extract code to handle disk read write. So, with abstraction, the OS already provides ready-made methods to read or write from the disk. The programmer can focus only on the stock analysis program, not on how disk works. Here's the final point. To the programmer, abstraction is very important because it saves the time and effort. To the user, it is invisible. They don't care how it works actually, but it makes software development much easier. Here it is a so super simple. Resource abstraction is OS heights. Hardware complexity. Programmer works on main task, not on the device details. Okay. Do you want now coming to another topic, which is user mode and kernel mode. Here there are three different types of headings for it. First one is processor and user mode. Second one is dual operation of OS or user mode or kernel mode. Firstly, modern operating systems work in two modes. First is user mode and second one is kernel mode. Now, the CPU switches between these two modes depending on the type of programs or tasks. These modes help protect data and provide security. So please enter these points in your book that it can help you in other things also. Now coming to user mode firstly. Here it is given it has restricted access to the resource. CPU has restrictions. Therefore, it can have only access to limited instructions in memory. In simple, It runs normal applications like text editors, media players, browsers. Here it have a limited access which cannot directly access hardware or memory. It has mode bit 1. If a programmer needs hardware access like reading from disk, printer, etc., it asks the operating system through a system call. Now the CPU temporarily switches to kernel mode to do the task, then returns to the user mode. Here there isn't one single advantage which is given, that is keeps the system space. Now, it means programs cannot damage hardware directly. Okay, now that was all about user mode and it is all about kernel mode. Here kernel mode is also called as supervisor mode or system mode or privileged mode. This mode has full access to memory, input and output other resources. In this mode, CPU can execute any instructions and have full access to underlying hardware. So, it runs the core operating system tasks. That means full which have full access. You can use memory, CPU, input output devices, storage, etc. And it has mode bit of 0, which handles low level operations like reading, writing to disk, memory management, device control, etc. Here, all the system level processors runs in kernel mode. For example of switching, you open a media player, runs in user mode, which runs in user mode. Media player wants to read a song from hard disk. Now it goes and requests to operating system, which is system cell. This will come in your next video about all about system call. Now let's just focus on the kernel mode and user mode. Now CPU switches to kernel mode, which here this kernel mode reads data from the disk. Now CPU then switches back to the user and it gives media player to continue playing the song. In short, user mode is equals to safe restricted for applications. Now kernel mode is powerful full access for operating system tasks. Here features and user mode. First feature is about access, which has limited and no direct hardware. Who runs here? Applications and utilities. Mode bit 1. Safety, safe and restricted access. This is all about today's topic. Meet you in the next video. If you are new to this channel, please do like, share, subscribe. Bye guys.